So welcome back. So we're still continuing on with hormones, but now we're going to talk about pancreatic hormones and diabetes. So let's go ahead and get started. All right, so when we think about our pancreatic hormones, we usually just think about beta cells, right? But don't forget that the pancreas actually has 3 hormones that it secretes, okay? It's alpha cells, beta cells, and then delta cells. Now, those alpha cells, what do they secrete? Right, glucagon. Okay, good. And glucagon responds in a fall of glucose. So when you have a decreased glucagon basically goes and converts glycogen to glucose. So it goes and stimulates the liver to convert glycogen to glucose, which is also called what? Right, glycogenolysis. And when that happens, you have an increase in blood glucose. All right, so that's the alpha cells. Now, the beta cells, those are the ones that we think about when we're talking about diabetes, right? Because we all know that beta cells secrete insulin, good, and insulin does what? Yes, it moves glucose into the cells to be used for energy, correct? Awesome. All right, then the last one is those delta cells. Now, delta cells secrete somatostatin, and we've talked about this before, but what does somatostatin do? Right, it inhibits growth hormone, good. Now, I also put there just some other things that it inhibits too, because it also has an effect on our thyroid stimulating hormone, as well as our gastrointestinal hormones, which we'll see in a minute, okay? So let's get back though to insulin. Insulin does a lot of things, and I think this would be a great pick 2 question, because there's so many things that we kind of forget about it doing, and it's there in those bullet points. A couple things just to make sure that you guys realize though, is that first thing that we think about is it increases glucose taken up by fat and muscle. And then it also does glycogenolysis. It does glycogenesis as well as lipogenesis. I'd be aware of all of those, okay? All right, so then the other things that can happen then is if we don't have our insulin, well, what happens? Yes, you get your type 1 diabetes. That's the first thing I would think about. And this is the kiddo because, again, usually younger people get it. They are thirsty all the time, they pee all the time, they often complain of stomach aches, and the treatment for that is to give them insulin. Now, a couple of other things that type 1 diabetics also have, and they're in those bullet points there too, but hyperglycemia, besides that, they can get hyperlipidemia, and of course, these are the patients we worry about getting the ketoacidosis as well, because instead of having the ability to break down glucose, they end up breaking down fatty acids and proteins, okay? All right. So then we got our type 2 diabetics. Now remember, type 2 diabetic is fluffy grandma, right? So this is not an issue of not having enough insulin, although sometimes you can have some beta cell dysfunction, but not nearly to the extent of a type 1. But the type 2 basically is because of peripheral resistance. Remember, the insulin just can't be used appropriately. Good. Okay, so then the last one we talked about was somatostatin. Now, somatostatin I just referred to can also work in the GI tract. And in there, I put a bunch of bullet points that you can see. There's caused of inhibition of intestinal glucose and triglycerides absorption. Also, its release from the pancreas is stimulated by amino acids, glucose, fatty acids, as well as GI hormones. So those are the things I'd be aware of there. Now, we're going to move on then from the pancreas to the adrenal gland. Now, the adrenal gland has an outer cortex where we get our corticosteroids from, as well as the inner medulla. And now the adrenal medulla is what is our epinephrine and norepinephrine, remember? So first things first, let's talk about the corticosteroids, which would be your glucocorticoids as well as your mineralocorticoids. Now remember at the very beginning of the hormone section, we talked that these were derived from steroids or cholesterol. I'll give the answer away. And they're kind of what hormones? They're steroid hormones, right? Good. Sugar, salt, and sex, remember? So I put a list here of the glucocorticoids when we talk about cortisol because it does so many things. And this is like your long-term steroid use, right? So when we think about cortisol, we think, right, it can cause increase in blood glucose. It can cause prolonged wound healing. It promotes peripheral insulin resistance, all those things. I would know all of them, all right? It's just good to kind of go through and remember what they do because that's the same thing then that your steroids do when we talk about it in pharm. Okay, good. And then the next one is mineralocorticoids. And we've talked about that a lot. This is your aldosterone. And again, aldosterone, its function is to put salt and water back into the bloodstream, and that would increase then blood pressure. All right, good. So then we have the adrenal medulla. Now the adrenal medulla, this is your norepinephrine and epinephrine, okay? And this is your fight or flight. So that's kind of an easy way to think of it, because what happens here is when those are on board, you have increased liver and muscle glycogenolysis, and then you also have inhibition of insulin uptake by the muscles. You have an increased cardiac output, you have increased blood pressure, you have decreased urination. You have adrenergic effects then, such as your dilated pupil, which I know Kyle's covered a lot in pharmacology, as well as you're sweating, flushed, all those things, okay? So again, that would be your fight or flight, your catecholamines, okay? Awesome. We are done with endocrine. So let's go ahead and take a pause here, answer some more questions, and when we come back, we're going to be talking about muscles.